Hello everyone, welcome back to my channel. So today we are going to discuss another problem, but before going forward, if you have not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. So problem is Sum II. I would highly recommend that you can watch Sum problem if you haven't solved it yet. So I'll put the link in the description of that problem. You can go and see that problem first. So let's see what this problem is. In this problem, we'll be given 4 integer arrays, nums1, nums2, nums3, nums4. 4 arrays will be given of same length, like all are of same length. We need to return the number of tuples, like tuple has 4 elements. So we have to return how many tuples we can make such that one element from first array, other element from second array, third element from the third array, and fourth element from the fourth array. If we sum them, then sum should come to be 0. Sum should be 0. Right. So let's take this test case. We'll be given 4 arrays. These 4 arrays are given. And from each array, we need to find a number so that sum is 0. Like for example, from here, let's say 2. We take 2 from this array, minus 1 from this. Then we take minus 1 from this and 0 from this. So if you add these 2 plus minus 1 plus minus 1 and plus 0. So what we get 2 minus 1 plus 0, we get 2, we get 0. So sum is 0. So this is one tuple, this is one tuple, this is one tuple, right? Other tuple could be what? We can have another tuple that could be made, we can have is 2 from this, then minus 1, and then we can have what? We can have minus 1 and 0. So from here we can have minus 1 that we have taken, I guess. So other could be here. From here we can take 1. From here we can take minus 2. And from that one we can take minus 1, and from this we can take 2. So this could be one tuple which sums to 0. So all the elements, if we add them, all are coming to be 0. So this is one. So from these 4 arrays, 2 tuples can be created such that sum will come out to be 0. Right? Sum will come out to be 0. So output for this is how many tuples are there? There are 2 tuples. So output will be 2. Right? Output is 2. So now let's see how we have to approach this problem. How we will approach it. See, what we have to find is, we have to find, this is from nums1, we have to find a number. From nums2, that is this second array, we have to find a number. Let's say at index j it is. From third array, we have to find a number, nums of k. And so this is nums1, this is nums2, this is nums3, means this is the third array. And from this fourth array, we also have to find another number such that when we'll add all these, we will get 0. We'll get 0. Right? So see what simple we can do. Just pause the video and think the basic brute force approach. Like you need to find 4 numbers. You have to find 4 numbers which sum to 0. See what we will do. We will simply find all the quadruples. Like all the quadruples which are possible, we will find that. So we will have what? We'll have 4 for loops. Right? 4 for loops. In first we will iterate in this one, nums1. And then for loop in which we will iterate on nums2. Third for loop in which we will iterate on nums3. And fourth for loop in which we will iterate on nums4. And this, let's say this is I, this is j, k and l. So at last here what we will have, we will be generating, like we will be generating all the quadruples which are possible from these 4 arrays. So here we will have that condition that if nums of I plus nums of j plus nums2 plus nums3 k, like that one, if it is 0, then we got one we got one this tuple, right? We got one tuple, one quadruple or tuple. So this is like basic approach, basic, like we are generating all the quadruples which can be possible. So time complexity, as we know, size of each array is n. So here we have four nested loops, so size will, our time complexity will be O of n raised to power 4, right? O of n raised to power 4. So this is basic approach, brute force, right? Now we have to optimize it. Let's see how we can bring this to O of n cube, right? How we can remove one loop. So let's say we will be removing this loop. This loop will be removing. So for this, what you can do na? You can store. What you can do is what we are checking over here. If we have, see, if we have these all three, sum of these three, and we need to check whether in the fourth array there is this element or not, which when added with this sum will make the sum as 0. What we can do is we can store all the elements of this nums4 array. So over here this nums4 is given to us is 0, 2, right? So we can store this in a some data structure, these elements. Let's say we are storing it in a hash map. So in a hash map we are storing 0. Key will be the count, like this is the element, and here this will be the count, let's say, or you can take it, or you can ignore it also. So we'll be taking this, and actually yeah, you can store the count, because it might happen that there are 2 zeros here. So then there will be, you can store the count, right? So here count is 1, and for this 2 count is 1. So we are storing the elements of this fourth array in this hash map, right? After that, see, what we can do is we can just simply run this loop, run these 3 loops, right? We will run these 3 loops. Every time what we'll get over here, we can get nums of I, we'll get nums 1 of I, nums 2 of j, and nums 3 k. These elements we get. Now we will simply check whether 0 minus c, 0 minus all these will be what? Will be equal to, if you bring all of these to the right hand side, then it will be 0 minus all these, and that will be equal to nums4, right? That will be equal to nums4. That is, we are finding what is nums4. So what we are doing over here is, if 0 minus all these, that is, this value should be our nums4. This nums4 L, this should be our that value. So if this is present in the hash map, means there is one quadruple, one tuple we found, right? So this is one way. If this whole value, this whatever value comes, if it is in map, because in map what we are storing all the elements of this fourth array. So if, and this value is what? This value is fourth value. So if this is in the hash map, so we found a tuple which will be, when added, will give the sum 0. So this is one approach, right? And we know that searching in the map, if we are taking unordered map, in the average case, searching will be O of 1. Right, O of 1 will be searching time for hash map. So this is now reduced to O n cube, right? It's now reduced to n cube. So by using a hash map and storing the values of the last array, we have reduced it to n cube. Right. Now let's see how we can reduce to O of n square. So let's say we have this array. So array is, this is 1, 2 given to us. So 1, 2, this is the first array. Second array is 2, minus 1. And third array is minus 1, 2. And the fourth array is given to us is 0, 2, right? So now earlier what we were doing is we were using 3 loops: for loop, for loop, for loop. This is for first element nums1 I, this is for second element, this is for the third element, and the fourth element was in the hash map. That was in the hash map. So this we were doing right now. Now what we need to do is, in order to reduce it to n square na, we will have to remove this loop. This loop. This loop is for the third element which is in the tuple na. Tuple has 4 elements na. So this D1 we stored in hash map. This third one now we need to do something about this, because we need to remove this loop and make it n square. So what we can do? Guys, just pause the video and think how we reduced this loop. How we reduced this variable and like this loop for this variable. So I hope you got the approach. What we will be doing is, see, we know that over here in the problem what we need to find? We need to find whether there is any nums1 of I plus there is nums2 of j plus nums3 of k plus nums4 of L, like this index. Is there any these elements in these 4 arrays such that they sum to 0, right? This we need to find. Now if we know these two, elements, for example I know these 2 elements and I have to find these 2 elements. How can I find? See, nums3k plus nums4l, that is these 2 elements will be what? Equal to 0 minus this whole thing will go that side. So nums1 of I plus nums2 of j. This is the way we can find, right? This is the way we can find. So what we will do, see, we will be earlier we were storing in the hash map, we were only storing the 4th element, the 4th array, all the elements of the 4th array we were storing. Now in the hash map, in the map, unordered map, we will be storing pairs. We will be storing all. This is your nums1, this is your nums1, this is your nums2, this is your nums3, and this is your nums4. So we will be storing all these pairs of these 2 arrays which can be there. So we will run a for loop between this nums3. So nums3 will be the outer loop, nums4 will be the inner loop, and we'll be storing all the sum of all the pairs. That is -1. What all pairs can be for this? These 2 arrays, what all pairs can be? -1 and 0 could be there. -1 and 2 could be there. See, 2, 0 could be there, and 2, 2 could be there. So these, it might be that these 2 are the nums3k and nums4l. This could be, or this could be, or this. So this sum we will be storing in the map. So and the count also. So here the sum will be there, and here the count. How many times that sum is coming. So yeah, here -1 plus 0. -1 plus 0 is what? -1. Sum -1 plus 0 is -1. So that is occurring for now 1 time. Then we will go to this. -1 plus 2. This is what? 1. And currently initially count will be 1 only. Then 2 plus 0. 2. And count 1. And 2 plus 2 is 4. So 4 and count is 1. For example, over here, let's say it was here, it is 2 comma, let's say -1. It's 2 comma -1. So here 2 comma -1. So sum will be 2 minus 1. It will be 1. Sum will be 1. So here 1's count will become 2, because there are 2 for 2 having sum 1, right? So that's why we are taking count. But right now let's take over here 0 only. Let's take 0 only. So this way we have created a map. So we will have a for loop. We'll have a for loop initially for nums3 elements and num4. This will be a nested loop, and we'll be storing sum of all the pairs which are possible for these 2 arrays, and we'll store them in a hash map. So this is we have done right now. After that, see, it's simple, right? What we will do is, We will be finding all these we will be having a loop, for loop, and we will be going to each element in nums1 and nums2, right? We will find whether this is present in the map or not, whether this is present in the map or not. If it is present, means we got our nums3 and nums4. So that is a tuple. Let's see how. See, what we are doing now is, we have this 1 comma 2, this is our nums1, nums2 is -2 comma -1. So this is I and this is j. So I and j are initially at 0 index, 0 1 0 1, right? What we will do is, first of all, we'll be finding nums1 nums1 I and nums2 j. So here I is here, so I is 1, nums of I is 1, and this is -2. So 1 -2, this will be -1. So this will be what? 0 minus -1. So this will be 1. That is, is there any sum? Is this 1 in the hash map? Yes, it's in the hash map. Means we got nums3, we also found nums3 and nums4, such that they add in this sum of this and we get 0. So this is one tuple we got. So we will have a count variable and we will increment it by, earlier it is 0, now we'll increment it by 1. So this, we found one tuple. See, 1 -2, and this 1 was coming from -2 and 2, this thing. So we found one tuple. Now what we will do is, we'll go further. So j will go here. So 0. So now it will be 1 -1. So this is 0. So now 0 minus 0. 0 minus 0. Is 0 in the map? No. 0 is not in the map. Hence, we are not able to find any nums3, nums4 addition, such that sum of nums3, nums4, such that they are, when they add with this nums1, nums2, they get 0. So that's not there. So we will go ahead. Now j is completed. So what we will do is, see, this is simple nested loop. How we do nested loops. So I will go here now and j will be here now. Now again, what we will do is 2 minus 2. 2 minus 2 is 0 again. So 0 is not in the map. Go ahead, j will go forward. And now 2 minus 1. So this comes out to be 1. Now 0 minus 1. This 1. So here -1 is -1. That is, we are finding whether nums3 plus nums4, if -1 is there in the map or not. Yes, it's in the map. Means we got nums1 I as 2, nums2 j as -1, and -1, this we were getting from what? This we were getting from, I guess, we were getting it from -1 and 0. From this we were getting that. So 2 comma -1 comma -1 comma 0. This is one tuple. Right, so this is the way we are reducing it from n cube to n square. We are storing the sum of the last two elements in the map, and then we are just running the loop for these first two, and when we are just checking whether the nums3, nums4 are in the map. So if they are in the map, we got a tuple. Right, I hope you understood the approach. Let's see the code once. If you understood the approach, code is very simple. If you remember, first of all, what we were doing, we were storing all the nums3, num4 these pairs in the map. So nums3 and nums4, we have nested loop, and we are in the map. We have taken this map, and in the map we are storing this in the map. So you can, over here you can use an unordered map, unordered underscore map, right? So, and we are storing this sum in the map. So if the sum is there, so count will be increased of the sum. If, like we discussed now, that if there are one sum is again coming, so its count will become 2, like that. So after that, we have taken this count variable, and we are just going to nums1 and nums2, and we are just finding whether In map we have, you can write 0 minus this. If this is present, just increase the count by how many times this sum is present. For example, over here let's say -1 was present 2 times. So this means that there will be 2 tuples found. 2 tuples will be made. One will be 2 comma -1 comma sum x comma y, which were x plus y, which was coming -1, and some 2 comma -1, something like 2 comma -1 and some value, let's say p comma q, something like that. So that's why we are incrementing this count. So after that we can return the count. Just dry run once this algorithm on this test case. You will understand how it's working. And if you found the video helpful, please like it. Space complexity is the constant. We are not using any extra space. Yeah, we are using extra space. We are using this map. So we are using extra space. So this map will have O of n space complexity. Right. It will be actually n into n. Why? Because we are generating all the pairs, na? So space complexity will be O of n cross n. Because all the pairs, nums3 and nums4, all the pairs we are generating, there are 2 nested loops. So n is the size of the arrays. So n into n. So time complexity is O of n square, and space complexity is also O of n square. So if you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video. Thank you.